Think of a classic video game character jumping across a screen. When you watch that hero leap, is anything actually moving inside the monitor? If we zoom in, we see the screen is just a fixed grid of tiny squares. Nothing travels left to right. Instead, individual pixels are switching their states on and off, thousands of times a second, toggling between zeros and ones. The computer inside the console is doing math. It calculates where the character should be, then updates the color of the pixels on the grid 60 times every second. What feels to us like fluid, continuous motion is a byproduct of the speed of these data updates. If the system calculates fast enough, our eyes can no longer see the gaps. If we take our eyes off the screen and look around the room, we can ask a similar question about reality. What if the physical world operates using this same mechanism? Some physicists are exploring the idea that space is not a continuous empty void. Instead, it might be a three-dimensional grid made of microscopic, fundamental compartments, each one existing solely to hold a tiny bit of binary data. In this model, physical matter, like a coffee cup, an apple, or your own hand, is a dense cluster of information registered onto specific cells within this cosmic grid. If everything around us is ultimately made of data cells, then the laws of physics are the software code telling that data how to behave. If the universe is running a program, it changes how we look at gravity. Why do objects pull toward each other? To answer that, we have to look at computer memory. On a hard drive, random, scattered files take up extra resources to manage. In a universe made of information, disorganized data forces the system to work harder just to track the location and momentum of every loose piece. This diagram shows the problem. In panel B, randomly spread matter spikes the universe's processing load. As panel C shows, the code groups these scattered data points to save memory. By panel D, bits merge into one organized cluster, drastically reducing the computational effort. This process mirrors outer space. On the left, a sprawling cloud of cosmic dust represents a disorganized system, making it computationally expensive to track every particle. Over time, that dust pulls together into a single planet, compressing the data and dropping the computational load. Gravity then acts as an automatic data compression algorithm running in the background of reality, designed to optimize the universe's memory. If the universe is a machine optimizing data, how does time fit into the equation? Time acts as a cosmic refresh rate. Just like the pixels on a monitor, the clock only ticks forward when the universe finishes calculating its next frame of data. Scientists propose time operates in three distinct dimensions to process reality. The green horizontal axis handles the quantum scale, generating mass. The blue diagonal axis dictates particle interactions. Finally, the red vertical axis governs the cosmological evolution of galaxies. These three layers of time work in sync to render our reality, from the smallest particle to the edge of the cosmos. This perspective applies directly to you. If you look down at your own hands, you are seeing the result of this massive calculation. We typically picture ourselves as solid objects that were built once and are now just floating through the years. Instead, you are a knot in reality, an organized, complex cluster of data fighting to hold its coherent shape on the cosmic grid, even as a stream of new information flows through you. Rather than sweeping us away, time provides the computational engine that keeps us rendered, recalculating our structure frame by frame, second by second. The next time you look at a clock, realize it isn't counting down the seconds you have left. It is counting the universe constantly updating you.